Good evening and or afternoon or morning, ladies and gentlemen. Welcome to week 3 of the Maya 101 class, where we're going to take a look at the process of surfacing or adding materials and textures and whatnot to your various items in your scene. Now, there are several things I want to talk about today. There's going to be a lot of note writing and things that I'm going to be putting on the whiteboard. There's also, however, something that I want those of you who are following along to go grab or snag or be aware of. If you end up getting it kind of close to your break, that might work. I don't know how quickly we're going to get to it. Every class I've ever taught is a little different than the one before. But give me a second. I'm nailing a browser off screen. Let me bring the browser front and center for everybody. If you go over to the streaming files page, which hopefully all of you know how to get there by now. If you don't, note the address at the top of the page. As a member sponsor, you can jump right over to that. And there is a Maya classes section, and there are some Maya 101 textures that you need to grab. So get those downloaded post-haste. Also, you need to know where to put them. So once you got them downloaded, open up the little RAR file that's in there, and I'm going to show you where I want those to go in just a second. Doop-a-doop-a-doop. I've got to navigate to it myself. Let's see, projects, there we go, so that's close enough. So projects, and here's the Thursday class. If you go into your project folder, which you should have, I won't be hitting F10 this time, no worries. So if you go into your project folder, you want to place these in the source images folder. So take those two textures that you got, make sure they wind up in the source images folder, and that'll be good. As a matter of fact, let me go ahead and do that also on my end so that everybody is on the same page. Let's see, what's the fastest way to get to the desktop on this thing without really showing it to everybody? So here's one, and there's the other. So these are the two textures that should be available in there. Okay, so that's good. Again, make sure you do that once more. Those are available at 3dbuzz.com/VB forum/SVMS streaming files. So note the underscores, please. .php, if somebody would care to link that page in there, like I'm doing right now, there. That should help. So, and again, make sure you put those in the source images folder, and you can see the path to that on my end. So if you're using Windows 7, you have a similar path. It's going to be under C users, your name, your documents, Maya, your projects, whatever your project is, source images. That is, unless you made your Maya project somewhere else, obviously. So if you've made your project some other land on your computer, then please make sure you point it in there. The reason we do that is that later on, once we get to creating our actual file nodes, we need to point those file nodes at textures. When you say, hey Maya, I want to drop a real file into this node, it looks in here first. So if you go ahead and put the files in here, you won't have to search for them later. It does speed a few things up. Okay, so here we are back in Maya, and let's see, I've got, well, that's my whiteboard from the last class. Let me go ahead and kind of clean that off and hide that. And there we go, and so there, now this is looking better and better by the second. Here you go. How about just one great big empty screen of darkness? By the way, folks, I have a brand new monitor set up for teaching this class, so if it takes me a second to kind of remember where things are, essentially what I did, and I'm a little frustrated by it, so if you hear like an edge in my voice, you'll know why. I have a big monitor and I have a small monitor. My big monitor is 24 inches. I know, there's a lot of folks who have bigger ones. And my smaller monitor is a 19. Well, what I've started doing now is I am recording my classes. Actually, what you guys are seeing is on my little 19, and I've taken my great big 24 and I've put that off onto the side. So that's where I've got BuzzNet going and the webinar and all the other stuff, just because I was running out of screen space. But I'm working on a smaller screen now, so if you sense a little bit of frustration, at least you'll know why. And I need to really quickly change out my Wacom tablet because right now it's currently slaved over to the other screen. So let me fix that. We want you to follow this monitor. Haha! Beautiful! Look, I can see now. That makes all the difference in the world. Alright, so what are we going to be talking about today? Well, today we are taking a look at surfacing. Now, what is surfacing? Surfacing is basically the the process of defining what the surfaces of your models are really going to look like. You might have heard this once or twice referred to, well, texturing is only a part of it, but you might have heard the term texturing. And we're going to talk about that too. They're not really the same thing, but they're pretty close. Texturing is actually a part of the surfacing process, but texturing doesn't really say everything, doesn't define everything. So there's some terms I want you to kind of understand that I want to get out of the way early on, and some of these you will have heard before. As a matter of fact, I'll probably be kind of going back and forth and asking which things you know and which things you haven't heard of, etc. and so forth. But we have materials. Has anybody here never heard the term materials? Hopefully I think we've even mentioned it here in this class. I don't see anybody really jumping up and down in BuzzNet, so you've all heard it. Now, is there anybody out there who does not know what a material is? And people are squirming. That's good. I like it when people squirm. All right, who knows what a material is? Who can tell me what a material is? And NATO, you hush. I know you know what a material is. I know. And then you'd be like Gavin, you'd answer all my questions. A set of instructions to draw a shader. That's pretty close. Yeah, I mean, that's a good solid definition. So, yeah, if you guys did UDK 101, you should already know. The cover of an object. Actually, everything I've seen so far is pretty much right on the money. But I'm going to kind of simplify things just because this is sort of a 101 class without getting into too many terrible technical terms. We're going to call a material just a definition of a surface. To be more specific, how light responds to the surface. So this means a material will define all kinds of things. It will define things like color. It will define things like shininess or specularity, as we'll end up calling it later. If there's anything like a bumpiness or a tactility to the surface that makes it, like if you ran your finger across it, would you feel all kinds of lumps and bumps? You can define all that sort of thing in a material, and a whole lot more, depending on the materials. Now, we're going to be keeping our material exploration fairly simple, just because of the nature of this course. But there are materials out there which are defined specifically to give you like a volumetric effect for like when you see fog inside of a flashlight cone. You know, when you see that cone of light going out and there's some sort of haze in it. There are materials specifically to create that effect. There are materials specifically for transparencies, like things like glass and crystal, so that you get a nice kind of reflection and refraction coming out of them. Again, though, we're going to keep this relatively simple, at least in this class. So that's what a material is. It's a definition of a surface. Now, you've probably also heard the term texture. And if you haven't, now you have. Now, what is a texture? Is there anybody in BuzzNet right now who can tell me what a texture is? I'm looking for one word in particular. Oh, Chris already got it. It's an image. A texture is just a picture, and that's really the way I want you to remember it. A texture is just an image. Now, I let people slide when they're just kind of casually talking, when they say, hey, I need to apply a texture to my object. That's not entirely the way it's going to work. You have materials that you will make in Maya. These materials are going to have several different things like color, shininess, bump, and all sorts of other things, each of which can be defined by a texture. So you can have a texture that defines what color something is, which is fairly obvious. You can have a texture whose only job is to map out what parts of an object are shiny. Consider, I don't know, what's a really good example of this? An ice cream cone. An ice cream cone where your ice cream is starting to melt, but you've built this all as one object. You would need a texture whose job, and I'll just draw a really quick ice cream cone. There's like the best ice cream cone ever. By the way, it's chocolate chip mint ice cream, because that's really the best ice cream. But, this is starting to melt a little bit in the sun. You would need the ice cream area to be pretty shiny and have a little bit of a specular highlight when it hit the sun. But the cone itself is not particularly shiny, and if it is shiny, it's shiny in a different way. And so you're going to end up with a texture to define what parts are shiny and what parts are not. So really, you can take that and use that to extend the definition of a texture. An image that defines some aspect of a material. And it's going to make that definition on a pixel by pixel basis. And when I say that, if that blows your mind, don't think too hard about that. Things like per pixel definition, because think about adding just like a brick texture to a wall. Each pixel of that image is being placed on a certain location of that 3D model, and so you could have some bricks that are brown and some bricks that are red, all because you have this picture, this image of a brick wall that had different colored bricks. Now, I've seen a couple of people discussing normal maps, bump maps, and all that sorts of thing over inside of BuzzNet. Hang tight, we're going to get to all that. So lots of discussion coming up here very soon. Okay, so a texture is just an image that defines some part of a material. So consider that textures feed into materials. So if you're working in Maya and you say, I need to apply a texture to my object, that's not entirely accurate. You need to apply a material to your object, and you will create textures to define certain attributes of that material. Now, you may have also heard the term shader. I'll just kind of slide this in. We're not going to be using it too much. A shader is going to typically be considered as an algorithm And when I say algorithm, I mean like mathematical equation, an honest-to-goodness math algorithm. That? What? Really? That defines light behavior on a surface. Now, inside of Maya, we can create several different types of material which are all driven by different shader algorithms, and we'll see some of those here in just a minute. I also just want to throw out there, I mentioned the term texturing earlier on. Texturing is really just the process of creating these textures, these images that will define some part of a material. Okay, now just knowing this, knowing generally what materials are, knowing that a material will be fed by textures to define certain aspects of it, and that those materials will then be applied to objects, that gives us enough to at least jump over into Maya for a moment. And here's what I want to do. I want to go ahead and set up our workspace for today and how we're going to be working. By the way, if you guys just heard a little bit of noise, maybe a deepish rumble come over the microphone, I don't know if you guys can actually hear that, but it just started a torrential downpour outside. It sounds like the heavens themselves just opened up. So if you start hearing thunder and stuff, I'm just getting a bit of a storm over here. No worries. Okay, so let's go to panels. Now, this is inside of Maya, so make sure everybody's in Maya and following along. Also, standard operating procedure for these classes. If you plan on following along and doing all the clicks and things that I'm doing, please make sure you check your participate button inside of BuzzNet. I have heard that certain web browsers don't show the participate button. I would recommend you switch over to Chrome if that happens. If you are not planning on following along, if you're just watching the video and enjoying the show, please don't bother with your participate button. Just leave it set to off. It'll make my life easier. Throughout the class, I'll be doing our standard ready checks where I ask people to set their status to ready. So if you're ready for me to demonstrate something, set your status to ready right now. This will tell me who's following along and who's not. Right now, Commando182 is not following along, and Rodan2000 are not following. Oh, Rodan's in. Commando, it's just you, buddy. Marilyn, how's it going? Commando, you're still... Oh, there you go. Good work. Mwahaha. Perfect. Okay, so everybody, go to Panels. And this is actually the long way to do this, but I just want to show it to you anyway, because sometimes you'll want to do this. Go to Panel, and then jump down to Layouts, and set this to 2 panes stacked. Like so. Now, I want you to take your lower panel, go back to your Panels menu, jump down to the Panel submenu, and set this to the Hypershade. Now, in Maya 2013, you have a brand new way to make materials by way of the node editor. I am not going to be ignoring the node editor. We will take a look at it at least once today. But I'm not going to focus too heavily on it. And here's why. The node editor is extremely useful, extremely powerful, extremely smooth, and extremely slick. But it is most useful if you already know what nodes are available and what nodes you need. So, because of that, we're going to stick to the Hypershade to get everybody started. Once you get a little more comfortable with slinging together materials inside of the Hypershade, then you can make a nice smooth transition over to the node editor, which is pretty cool. Now, your Hypershade may not look like mine. Your Hypershade probably looks a little bit more like this. My left side was all collapsed in. I use half of my left side. That's funny when you think about it that way. Generally, what I'll do is I'll take this middle divider and just split that and drag that all the way over to the left. So all I have is this little nice clicky list of all of my Maya nodes, at least for classes such as this. So really, all I want to do real quick is just show you guys something. We have a lot of different materials we can create. The entire first part of this list is just materials. And some of the notable ones that you'll be using a lot when you get started include things like Lambert, which I'm just going to create one of these. And also, I'm just going to show my work area for a moment, and I can do that by clicking on the Show Bottom Tabs Only button up here at the top of the Hypershade, and I'll stretch this out just so you guys can see a little more of what's going on. In fact, we could just slam it all the way up. I do kind of like that you can just use it kind of like a shade, and just draw the shades, and there you go. So we have a Lambert, we have a Fong, we have a Fong E. What are some of the other major ones? Blinn. Blinn's a good one. And anisotropic. Now, these are some of the primary shaders that you're going to be using quite a bit when you first get started. And what makes them all different? Really, the big thing that separates each one of these materials from the others is how they handle specularity. And you can see, if you look really closely, the specular highlight, which is that little shiny spot on each one of these sample spheres, is all just a little bit different. The names, for the most part, with the exception of anisotropic, yeah, that's it. The names actually come from the mathematician who developed the algorithm to define how light would reflect off the surface. So there really was somebody named Blinn, and somebody named Fong, and somebody named Lambert, and they came up with different algorithmic shaders that define these things. So, I just wanted to kind of point that out. The shaders are defined by, you can use a Fong shader or a Blinn shader, but really in the end what you're doing is you're constructing a material. And you'll make that material out of a series of different nodes, being textures, and usually some form of utility node, which we'll get into a little bit later today. Let's see. And Florin, you asked a question, and then you said never mind. Okay. So I'm going to delete all these guys. Now, that gets us through the first part, where we just kind of talk about materials and we talk about textures. There's one more thing, there's one more aspect of this that I kind of need to pound into your heads that gives some people fits. I know this, especially people who are just getting started will have a difficult time with this, but I need to get through it. I need to point it out to everybody. It's really not that bad. And this is the concept of UV coordinates. Now, who in this room, of course I'm looking over at BuzzNet, is completely unfamiliar with UV coordinates? There's a couple of people. All right. All right. So let's talk about these in general. First off, let's kind of get started slowly. I'm going to draw out, freehand, mind you, the most amazing 3D model that has ever been drawn in Photoshop. Right now, you're going to get to see it. Are you excited? You should be. And we're not even done. I'm going to give you guys the power to see through walls. That's right. X-ray vision, my friends. There you go. The most exciting model that has ever been, in the form of a polygon. Now we're just going to focus on texturing polygons. NURBs actually get, they kind of have their own texture coordinates inherent into them. So we're just going to leverage that. We're not going to worry too much about texturing NURB surfaces. So, every single polygon object you've ever made and ever will make is comprised of vertices. Remember that? That would be these little guys here and here. And all of it. Any time edges are going to come together and meet, you get a vertex. Now, here's where I get to blow some people's mind. A vertex has a coordinate in 3D space. It has a coordinate in X and Y and Z. Now it has to have that because it has a position in our 3D scene. We can move that vertex around, and as we move, thank you, Wick. I just want to stop the class just because Wick said the word vertexes just to throw me off. So, a vertex has a position in 3D space, and we can move it, and that location, that 3D space coordinate, will update. Well, here's the thing. Vertices also have coordinates that exist in 2D space. They have coordinates in U and V. Now, in some 3D packages, you'll see this called UVW, but we're not going to be worrying about W. U and V are coordinates that exist only in 2D space. Now, if you're totally new to this, you may be wondering, why would you need this? And I just saw a kind of an idle question roll in from Paul. It said, U is X and V is Y. You can't really say that. They are not analogous to anything. You can point U and V in any direction you want. When looking in 2D space, and let's draw that out real quick. So here's an example of two-dimensional space. And here's an example of 3D space. So we're very used to 3D space. We have, in the case of Maya, we have Y going up, we have X going one way, and we have Z going the other. In 2D space, instead, you have the U direction, which tends to run horizontally, and you have V, which tends to run vertically. But the two are not related. What do I mean when I say that? Well, this brick could be set up in such, this little block that we created, it could be set up in such a way where this face is, of course, facing upward, and of course the bottom face would be facing downward. But there's no reason why in 2D space we couldn't put the top face at the bottom of our 2D layout. So you can't really think of these two having any sort of relation. U is not analogous to X, and V is not analogous to Y. Just think of it as two entirely separate coordinates. Now, can anybody who wants to reach for a cookie, and hopefully, I mean, if you've known the answer for a whole long time, if you've been doing this before, consider refraining from answering. At least consider it. Rub your chin for a moment and stare at the ceiling. But is there anybody out there who can tell me why we need two different coordinate systems for every vertex? Because of reasons. Thank you, NATO. All right, well, nobody's really jumping in on that, and that's good, actually. Textures are 2D. That's a really good start. Actually, here's an interesting way to explain it. Let me jump this up. It turns out the biggest reason we have to do this, I'll just write down the basic answer. It is difficult to make a 3D object flat. It just doesn't happen very easily. Trying to take a three-dimensional object and flatten it out so that it can be loaded up in Photoshop is not an easy thing without destroying that object. If all you had were 3D coordinates and you wanted to lay this box out flat so that you could paint on it inside of Photoshop, you'd have no choice but to destroy the box. Let me give you kind of an interesting example of this. I just want to show you kind of how hard it is to go about this and how we've been struggling with the problem for a long time. As I almost knock over my coffee, but not quite. Mwahaha. Let's see. I'm actually poking around on the internet for just a moment. Here's. I think this is the one that I used last time, or it's very much like it. Here's a picture of the Mercator projection of the world, in which the three-dimensional object of the globe has been flattened out and turned into a map that you can lay on a table, or even in this case, I could open this up in Photoshop and I could draw around. And Ben's all over it right now. Take a look at Greenland. Greenland is actually, I think if I did all of the math on that, it would be roughly the size of, if not maybe a little larger than the bulk of North America. And the UK is, well, it's bigger than it needs to be. And you can actually see this taking place on the map. Do you see these squares, these latitudinal lines that define like longitude and latitude? Notice that as you get down here close to the equator, these have a very set rectangular size and ratio. But the farther you get from the equator, they start to stretch out. And that's exactly what's happening. Now, why is that? Because as you get closer to the pole, all of that has to be laid out and flattened. Here's a really quick quiz that I like to throw out there for anybody, just to make sure people are understanding this. How far is it from this point at the very top of the map to this point at the very top of the map? Take a guess. How many miles is that? Foe's got it. The answer is 0. Because all of these lines have come to a point. Essentially, everything that takes place between the North Pole and the South Pole has to get a little bit stretched out in order to be some way laid out so that you can put it on a table. Now, that's what happens when you flatten the world. You get distortion. And this actually brings up my next point. When trying to flatten things out, you usually end up with one or two things, or you'll generally, in 3D, you'll end up with both, and it's just a question of juggling which one you want to have more of. You will have distortion, and when I say distortion, I mean stretching, like what happened to Greenland. Or you will have seams. And even on the Mercator projection, where we have just one great big square, we already have the equivalent of a texture seam on the left side and on the right side. Because obviously the globe just continues. You can just keep going east on the globe until you die. You just keep going around and around and around and around. But on something flat, there's got to be some sort of a boundary or a seam. Now, let me jump over here and let me Google search again. I try to pull my Google searches off screen because sometimes you just don't know what's going to come up. There you go. Aha! And search for images. Oh, here you go. Now here's another approach, much smaller because I just did a really quick image search. Another approach to creating a world map that is arguably far more accurate. And again, the same thing has happened. It's the same problem. We're trying to take something that is spherical, the globe, and flatten it out. But in order to prevent as much distortion as possible, we've made some additional slices that result in all of these excess seams. Now this is exactly how UVs work in 3D. As you try to lay an object out flat, to take it from 3D into 2D space in a nice clean manner, you will have to basically decide whether you want distortion or whether you want seams. And it's always going to be that way. For instance, we have my cube up here that I drew earlier. I'm going to get rid of some of this scribbling. And if we wanted to take that from 3D space into 2D space, one possible way, and there are many possible ways, is to do something kind of like this. And there you have the kind of typical cross pattern for laying out a box. Now, what have we done? Well, we've essentially sliced this box or opened it up in such a way where all 6 sides of it are laid out flat. We have some seams. For instance, what's the distance in 3D space between this point and this point? 0. Again, they exist in the same location. And that's again where we get into the necessity for having 2 separate coordinate systems. This vertex in 2D space and this vertex in 2D space both exist at the same point in 3D space. So it's a little bit of a mind job if you're totally new to it, but you have to do it. Why? Because, and please nobody turn into a bit of a smartass and point out that with Photoshop Extended you can load in 3D objects. Let's leave that alone for now because you still need UVs. But you can't load a 3D object up inside of GIMP or Photoshop or your image editor and just treat it just like it is and natively paint on it. Even if you do the Photoshop Extended kind of stuff, you need you're going to need some sort of UV layout because it's going to need to know where you're actually wanting your texture to be placed. So what you do is you flatten it out in 2D space, you create these UV coordinates so that you could potentially open this up in Photoshop and say, hey, I want a smiley face on this side, I want a star on this side, and I want a circle on this side. So that once you go back into 3D, you end up with a smiley face here, a star here, and a circle down there on the bottom. That's how it works. That's why you need those. That's why they exist. Now, the process of making a nice UV layout, that's a whole different thing altogether. Because, that's one of those things that you will just have to kind of work on, and we're not getting super into texturing in this class. I would love to have a texturing class and just talk to you about the various ways in which you can make nice, clean UV layouts. If you're absolutely dying for some more info, I would highly recommend you check out some of the videos available over in the ADP class once you get done with this class. So, there's a quick rundown of how all of that works. Any questions so far? I mean, I guess I don't even need to ask, because if you had them, hopefully you have already put them over inside of the question panel. All right. So this brings us, what resolution is your notes image? 2048 by 2048 generally is what I work with. And I can hand these out to people on request if you need them. You can, I'll work on that later. So and that'll depend on who's actually interested. Okay, so, or how many people are interested, I guess I should say. So the next thing I want to talk about is the creation of materials in Maya. Inside of Maya, as I mentioned earlier, we have materials which have textures that plug into them, and those materials are then applied to a surface. When you're making a material in Maya, you need to keep a few things in mind. Materials, like everything in Maya, but it's kind of a special case with materials, are all made out of nodes. You will have a node specifically for your material. This material node, and we actually saw those just a second ago when we were looking at the Phong and the Blinn and the anisotropic, etc. and so forth. When we were looking at all of that, we were looking at material nodes. And what this contains is various attributes that are specific just to that node. So things like, what color is it? How shiny is it? Does it have some sort of a bump or lumpy sort of surface? And all of these can be considered like inputs into which you can plug information from other nodes. So for example, I can make a texture and that texture can be plugged into the color. So that whatever color was demonstrated on that texture shows up on the surface of my material. And if you really want to see how all of this kind of relates, your UV coordinates, which I'll just leave as kind of a circle floating out here in space, will define how that texture gets placed. So that's where it all kind of comes together. Incidentally, there's another node that automatically comes in with a file texture, and comes in with a lot of other textures too. I think every texture, come to think of it. A 2D placement node. And his job is really just to cover things like, are we scaling the image? Are we repeating the image? Are we offsetting the image somehow? And various other things. So that gets plugged into the texture, which then gets plugged into the material. And you can have other textures as well. Whose job may be to define how shiny something is. And you may not even need certain... actually, let me go a different route. You could have a texture that defines how lumpy and bumpy something is, and there's another magic node we'll talk about that goes in between here. I just don't want to mislead anyone. So we can define the bump, but we don't have to have textures. We can just plug in a numerical value. For instance, we could say that this has a 50% kind of shininess to it. Now, all of this, these massive, or can be massive, the ones we're going to make today are relatively simple. But these node networks, and here's where you get to sound all smart around all your friends and everything, are really just a way to graphically define what is called shader code, or programming code. In the end, all of this is being translated into code which is fed into the rendering engine so that it knows what your objects look like. It's just instead of having to type that out yourself, you are creating it all by way of these massive networks. So that's how that works. All right, is the 2D placement tied in some way to the UV looking at the nodes? Not really. The 2D placement is sort of a separate way to handle this. For instance, it's kind of like just a beneficial addition to the system. For instance, let's say we're not trying to be so precise here. We don't really want individual pictures on each side of our brick, okay? Let's say instead, what we want is just kind of a generic, sort of chunky, kind of, gritty, grainy, rock-looking texture that we created over inside of Photoshop. Now, we still need to create a UV layout, because if we have nice squarish sides over in 3D space, but then over in 2D space we had something like this, then our image would get heavily distorted on this side. We'd see all kinds of nasty stretching, or squashing in this case. So you wouldn't want to do that. So you still need your UV layout. However, let's say you get done with your little granite texture, and you find that the chunks of granite and like the little speckles and freckles all over the rocks just don't look as small as you wanted them to. You're like, well, I mean, that looked okay at first, but now I need those to be a little bit tighter. You could take your 2D placement node and boost up the repetitions of that texture and tighten those up. Basically put more copies of that texture across the surface. And we're going to take a look at that a little bit later today. So where your texture and you could, if you wanted to, you can do the same thing inside your UVs. But if you don't want to disturb the UVs, if you already have a nice layout that may work for some objects that you want to leave alone just as it is nice having a node where you can just change a few settings, and just by plugging in some different numbers, you then have the ability to make updates to how the shader is laid out. Or if you need to maybe scoot the texture around. This is critical thinking time. It may not be ideal for everybody out there. If you feel yourself confused by this, understand that what I'm about to throw out is it's kind of advanced, and I think you'll start to understand it the more you play with texturing, though I'm pretty sure, we do explain this over in the ADP class. Your texture area inside of Maya is square. It's not rectangular, it's not trapezoidal, it is a perfect square. Not saying that what I just drew is, but that's what the surface is. What if you have a texture that you created which is rectangular? Maybe it's only half the size of this. So your texture could be something like, I don't know, 512 by 1024. And I've done enough Unreal stuff where I'm generally always doing like powers of 16 for like everything. But if you had a texture that was like this, and it actually could have your brick texture in kind of a squashed version. Where everything was kind of squashed down. What do? Well, you can use your Place 2D texture node to adjust the scaling along the V-axis and essentially stretch out this texture so that it fills out your entire texture area. So that would be the work of the Place 2D texture node. Is a script generated out of my networks, not one that you have easy access to. I mean, that's all going to be underlying code. That would be source code and the way the rendering engine is translating that. So if you had access to what the rendering engine was actually processing at the code level, then yes. But no, you don't actually get access to the scripts themselves. Okay, so no other questions so far. Things are looking pretty good. Let's go ahead and take a look at creating our first material over in Maya. So if everybody would, go ahead and open up Maya. And we're going to begin very, very simply. And I'm going to give you all sort of a heads up. In this class, my job, my role, my task is going to be to create a material for our plate and a material for the table and a material for our cake. When we're done with that, everything else will be up to you guys. And Engage just asked if you did that sort of scaling, wouldn't you stretch pixels, i.e. ugly? One, yes, you would stretch pixels. Whether or not that's ugly is a long story. I mean, it could be depending on the resolution of your texture, depending on your needs at the time. Like, for instance, I try to discourage people from just automatically creating big, 1024, 2048 textures for every single thing they need. Take the extra time to consider what objects are really important in your scene. I mean, and the more you get into creating your own materials and textures, the more important this will be, and you'll see that. But think about it. If you have an object that is really, like, say this cup, let's say this is going to be what our render looks like. Let me go ahead and make that big with a spacebar. This is what our render is going to look like, and this is going to be our cup, but our cup is really going to be placed somewhere out here on another table. Do we really need a super high resolution texture for that cup? Now, your sense of pride or your sense of craft may determine, yes, we should. I should have a 4096 by 4096 texture, complete with bump map, specularity map, and I should take hours to paint that into perfection. But think about it. If that's going to be way out there in the distance, it's only going to be eating up a few pixels on the actual screen, and a lot of your work won't even show up. It would be, in a sense, the equivalent of taking the Mona Lisa, and here's the Mona Lisa real quick, and there's her enigmatic smile. And here's the weird layout of the land behind her. And taking the Mona Lisa and cramming it down to 4 pixels. What would the Mona Lisa look like in just 4 pixels? Nobody really has any idea. It'd just be like a couple of colored blocks. So you can't tell. Think about that. When you have something that is going to be in the distance, you don't want to spend a whole lot of time and a whole lot of process making it. Oh, you think it'll look better? Well, it might look better than this for sure. And if you're thinking that, well, if I leave this as a 4096 super high resolution texture so that it will look better in my render, guess what? You're probably wrong. You can make it pretty small and it will look amazing in the distance. Or if you absolutely have to, you can go ahead and make it 4096. But I mean, as a personal request from me, so that you don't get yelled at by a director or you don't end up with really long render times or end up crashing your computer, scale it down as far as it can possibly go before you actually save it to your final render scene. Is there something like automatic LOD? Not in this case, no. So keep that in mind. Maya is going to take exactly the textures that you feed into it and send those off to be rendered. So at the end of the day, you want to keep those as tight and as efficient as you can within reason. Now, in our class here, for academic purposes, I'm just going to be handing you some very generic textures, and we're just going to drop those down. Those shouldn't be considered standards for any reason. A lot of that has to do with what resolution you're going to be exporting out to. Are you saving out to like HD? Are you just saving out to something like 640 by 480, etc. and so forth? A lot of things to think in. You could actually set up a network that would allow you to change out the texture that is currently visible based on distance, but all of that information, all of your textures still need to be fed into the rendering engine. So it pays not to think of Maya as a game engine, at least at this stage of the game. So with that, now, is there anybody in the room who has a polygon plate? Me, yup. Okay, a couple people left with polygons, a couple people have NURBS. This plate just happens to be NURBS. So here's what I'm going to do real quick. I'm going to go to Modify, Convert, NURBS to polygons, and I don't even really care what my settings are, but I am keeping the original. So now I have a NURBS and a polygon plate. Everybody who has a polygon plate needs to do this one thing before we go any further. You need to create some UVs for your plate. Right now, if you select a polygon plate, and if you don't have a polygon plate, don't worry about it. We can go over to display. No, not display. That's not what I want to do. Yeah, we can. Window. That's where I want to go. Let's go to Window, jump down to the UV texture editor, and oh, it opened up on my other monitor. Here are the current UVs for our plate. Now, yours probably look a lot more jumbled than this. They could look crazy, depending on how you ended up creating your plate. And, oh no, oh NATO, I just updated my file because I forgot to update my polygon plate. Pfft, whatever. Sorry, got me all confused there for a second. It looked important, the way you put that. Okay, so what I want everybody to do who has a polygon plate is select it, press the F3 key, function 3, up at the top of your keyboard to make sure you're in the polygons menu set. If your other hand is busy, just go over to your drop down here in the status line and choose polygons. Then go to Create UVs, jump down to Planar Mapping, do not click yet, wait for it, and click on the Options box on the right-hand side of Planar Mapping. And somebody just said, how would we know if it's NURBS for other people? Well, there's a couple of different ways. One, just right-click on it. If you see things like control vertices, isoparms, hulls, surface patches, that's a NURBS object. If you right-click on a polygon plate, you'll see things like edges, vertices, faces, etc. That's how you know which one you have. And if I were you, I would make a special point to be able to tell just by clicking and looking at something generally what it is you're looking at, whenever possible. It will help you in the future. Next, okay, so now that kind of threw me off, so I'm going to start all over again for the benefit of everybody. Select your plate, go to Create UVs, Planar Mapping, open up the Options box, and set this to project from the Y-axis, from the vertical axis. That means you're going to make a projection from straight up in the air to straight down at the surface of your plate. Click Project. And here's what that's going to do. You go to Window, back over to the UV texture editor, and now we have a nice layout of texture coordinates that coincide with the shape of our plate. There's something kind of fancy going on here. That means any texture we place at the top of the plate will be visible on the bottom of the plate too, but we're not going to stress that right now. We're going to keep things fairly simple. Okay. So, is anybody experiencing sound issues with me cutting in and out? Okay, well then that's all good. So again, everybody who has a polygon plate, you want to select that one more time, create UVs, planar mapping, you want to choose the Y-axis and click project. Just make sure you've done that. That is all. If you have a NURBS plate, you don't really need to do any of that. We'll leave it alone. Now, hopefully everybody has their Hypershade set up on the lower panel. If for some reason you don't, if you forgot to do that, or you didn't do that, or you don't think you needed to do that, you're wrong. Here's what I want everybody who hasn't done that to do real quick. Let's go to Layouts. Let's go back to a single perspective view for a moment. I want you to go under Panels. Go under Layouts and choose 2 panes stacked. Take your lower panel and make sure that that is set to the Hypershade. So go under Panels, Panel, and choose Hypershade. You have to do that. And if your Hypershade looks like this, what I want you to do, everybody needs to click on Show Bottom Tabs Only, so you only have a work area. If you see your 2 lists here on the left-hand side, just take the little middle divider bar and slam it over. We are now going to create a material for our plate. Here's how we're going to do it. Click on the Fong button. That will create a Fong material for you. Now, just to see who's following along, I'm going to do a quick ready check to see who got that. Cool, you've got your material. Now, I'm going to hold down the right... There's a couple of ways to do what I'm about to do, but here's the way that I usually do. Hold down the right mouse button and go to Rename, and this allows you to rename this material. And here's what I'd like you to call it, but you can call it anything you want. You can call it baseball if it makes you happy. We're going to call this mat_plate. So I know it's a material, and I know it's for the plate. So that's all I really, really need to know. Now, double-click on your new material, and that should bring up the Attribute Editor, which gives you access, of course, to all of the attributes for this material. And the first one I want you to change is color. So just click on that color swatch, and make your plate any old color of the rainbow, anything that suits you. It makes no difference to me what color you make your plate. So I'm going to do a red plate. I think I did a blue plate in the last class. I'll do a red plate this time. Why don't you just control double click to rename nodes faster? I love that. Why don't we do all kinds of things? Because I can do this one-handed generally. It's just something I'm used to. That's one of those things about hotkeys and shortcuts. It's really every bit of it, a matter of preference. Alright, so once we have that, I want you to apply this to your object. Here's my favorite way to do that, but I'm going to show you several different ways. I just middle mouse drag and drop onto my object in the scene, and that applies. Now, there are other ways to go about this as well. You can select your object in the view, hold down the right mouse button and choose Assign Material to Selection. That will do it. Another way is to right-click on an object and choose Assign Existing Material, and you'll see Matte Plate right there. That will also do it. And even another way is to press F6 to go to your rendering menu set, and with an object selected, you can go under Lighting, Shading, and there's Assign Existing Material there as well. So it's all over the place. But really, when you have the Hypershade open, I find the easiest way is just middle mouse drag right there to the object. Unless you need a complex selection, in which case I make the selection, hold down right mouse, and just choose Assign Material to Selection. My plate is not radioactively red. That is the exact Pantone color of a red Solo cup. True story. Not a true story at all. I totally made that up. But it's pretty close. Okay, so once you have your material assigned, what I want you to do next is scroll down. Now, there are several different properties on a material, and I do want to kind of talk briefly about them. I can't go into the nuts and bolts of each and every one. But we have color. That's pretty obvious what that's going to do. We have transparency. Feel free to play with the slider, and it will become fairly apparent what that does. You get a ghost plate. We have ambient color. Think of ambient color as what color you want the darkest part of your object to ever be. Generally speaking, you'll want to leave that at black, but sometimes you won't. If we kick that up to gray, you'll notice my sphere here tends to brighten up. That's because even the darkest areas that are receiving no light whatsoever are now this level of black. They're much lighter shaded. This will tend to make objects look like they're emitting a little bit of light, like they have a little bit of glow. You can use this to your advantage for things like characters' eyes if you want them to look just a little bit more vivid, or plant life, or skin shaders. You can give them just a little bit more life, and in a way, it kind of starts to simulate subsurface scattering. Next, you have incandescence. This gives the illusion that an object is emitting light. Just the illusion, because if you click render, it won't actually behave like it's emitting light by default. You can use Mental Ray and Final Gather to feed the incandescence channel, or make the incandescence channel feed into your scene and actually emit light. But by default, it's just an illusion. Bump mapping, we're going to talk about. That's coming up next. Diffuse. This is kind of like an overall multiplier for how much color information is going to be applied. You can really drive your materials way over the edge if you leave that set up to 1. So its default is set to around 0.8. And of course, if you pull that all the way down to 0, you get nothing. Translucence, depth, and focus all have to do with setting up the calculation for translucence on your object, and think of candle wax. Think of how light will pass through a candle and you can see the whole candle starting to glow from within. Gummy bears are another good one, Streeter. So yeah, anything like that where light can get through but you can't necessarily see through it, that's going to be translucence. Leaves are another really good one. I don't know if I would necessarily do it with skin. I mean, you can, but I would probably switch up to like a subsurface scattering shader if I was going to be hardcore about it. Next, we have the specular shading area. This will change depending on the type of material you're creating. So a blend material has an entirely different set of specular shading properties than a Phong. Here with a Phong, we have cosine power. This controls the size of your specular highlight. So a low cosine power, you get a great big fuzzy specular highlight. By the way, that effect tends to make objects look a little bit more metallic. And a high cosine power gives you a really tight specular highlight, which makes objects look a bit more shiny. Or glassy, that's another good one. Specular color. It's just controlling the color of that specular highlight. I would try to avoid pushing that out to full white whenever possible, because you can get basically run past the gamut and you have parts of your highlight which are pushing to full white. I try to avoid full white and full black whenever I can. But I will mention this. If you are trying to build something that you want to look a little bit metallic, remember that metals have the property in terms of light reflection of imparting a little bit of their color into the specularity because of microfaceting. So if I wanted this to look kind of metallic, I would have a nice big specular highlight. I don't know if I'd go all the way down to 2, but maybe somewhere in that range. Then take my specular color and tint it very slightly toward red. And that will start to give us a much more metallic look. So just something to kind of throw out there. I'm going to set this back over to gray and put my cosine power at somewhere close to 30, just for this particular plate. Reflectivity and reflected color. Reflected color is how much, is there any sort of color you'd like to influence colors that reflect off of this? Generally, you're going to leave this at black. In my opinion, you will know the times when you want to modify the color reflected off your objects, but in most cases, I just let the renderer handle that. If I have a red object, I want red color to reflect off of it, and that's fine, so you just leave it at black. Reflectivity, kind of the bane of my existence in a way, especially if you're going to be doing renders out of mental ray. The reason is that by default on all materials, this is set to 0.5. That means all of your objects already have 50% of a mirrored surface to them. That really slows down your renders, so usually the first thing I will do is take my reflectivity and slam it down to 0, and then roll it back up for objects that I want to be a little bit reflective. Now, I want to do a couple of really quick test renders before we go any further, and we're going to do that first by going, everybody, follow along and do this if you haven't already, and even if you have, you can double check. I want you to go to Window and open up Settings, Preferences, and jump down to the Plugin Manager. Again, that's Window, Settings, Preferences, Plugin Manager. Last time, Window, Settings, Preferences, Plugin Manager. Open that. And here's what it looks like. I want you to scroll all the way to the bottom and make sure that Maya to MR, that's your Mental Ray plugin, is both loaded and set to auto load. And just close that when you're done. You need that, otherwise we won't be able to render out to Mental Ray. Next, in your status line, you need to open up your render settings window, and that is this little tiny clapboard that had these two circles floating next to it, and that will open up, ta-da, render settings. Inside this window, make sure that you set your renderer to Mental Ray. If you don't see Mental Ray, it's because you did not do the first part of my instructions, which were to go to Window, Settings, Preferences, Plugin Manager, and activate the Maya to MR MLL plugin. So make sure you do that. So you can set this to Mental Ray. And I just want to show you something real quick. I'm going to set my reflectivity up to about 0.3, I guess. We'll zoom in here kind of on the plate, and I'll just do a quick render. And there's a little bit of reflection going on in there. You can start to kind of see it. If we crank this all the way up, it's not going to be easy to see just because of the nature of our scene, which is very simple right now. If we crank that all the way up, you get some heavy reflection from the sides of the cake. So it's just a question of how much reflection you want. Generally, I don't think you're going to need very much, so I'll leave mine pretty low. Now, I'm going to do a quick ready check and see who has this material. Okay, I saw a couple of questions come in. Somebody said, I don't have the menu when you right-click. Just hold down the right mouse button, that'll take care of that. What is the difference between Quick Render and IPR Render? Quick Render will actually use the native, whatever rendering engine you assign, to create a full render of your scene. IPR is the interactive photorealistic renderer. It, as far as I know, is only going to utilize Maya's native render. I don't know if Mental Ray actually, it looks like it does. Okay, so this does Mental Ray as well. And this will automatically update as you make changes. So if I come over to my color and set this to blue, it does a really quick update in that area. Now, I generally don't use this that much anymore. I have found that I'm not going to call it obsolete in any way. You can still use it for all kinds of fun stuff. However, with the advent of high-quality rendering, which makes your plate look funny until you hit the 3 key on it, by the way, or Viewport 2.0, which works really well on my computer, I find I really don't need it. I can get just as much of a preview as I really need out of that. So there you go. And if none work on your computer, then by all means, check out IPR. It can kind of speed things up. Or what I'll do more often than not is I'll just do a render, and I'll select a region that I want to fine-tune, and I'll do a region render, which is this little tiny red box here, and just render out that region, which is also very quick. Yeah, I have a 580 GTX NVIDIA. Okay, so we are at about an hour. We still got a little bit to do on this material, but I want to go ahead and take a quick break. When we come back, I'm going to talk to you guys about bump mapping. We're going to add a bump map to this material just to give it a little bit more visual flair. Then we are going to create a material for the table, and then a material for the cake before I hand things off to you guys. So that will wrap up this video, and I'll catch you guys in the next one. For those of you who are actually attending the class right now, you've got about 10 minutes.